I'd now like to turn the floor over to K.Aas, who's the Deputy Digital Archivist for the National Archives of Estonia. K.Aas.
Thank you. I need to say that I'm standing here being a bit nervous. The first reason is that it's been about maybe 5 years since I've talked about something else than eArc or digital observation interoperability at any of the conferences or events. And secondly, because I'm not necessarily a blockchain expert. Everybody else here on the floor has spent already, I don't know, years and multiple hours of working time on blockchain and discussing all the details, nasty details and technologies. However, for me, the start into blockchain was really about a year ago. As eArc was about to finish, then somehow Victoria found me and asked about the wonderful Estonia, which you saw already presented yesterday by Levi, and whether there is anything about blockchain. I found it an interesting question and decided to go at it, and without really any previous knowledge about blockchains, I started looking as a digital archivist on how the Estonian state is using blockchain technologies, what is the role of blockchain technologies as of now, and what is it actually for the archivists, which we need to know about blockchain, and what are the potential steps or kind of activities which we need to take in order to guarantee digitalization of information. So really the background, coming back to the slide, is that we at the National Archives of Estonia saw that there is increasing interest in blockchain technologies by the data creators. So the actual donors of data are starting to use increasingly starting to use blockchain, and that obviously also includes data of archival value, which means that it is going to become an issue for archives sooner or later. And obviously, this means that we need to know something at least about the technology in order to be prepared for any kind of blockchain transfers in future. An extra bonus which came out a bit later after I already started the use case is that obviously when you go through a technology, even if you don't necessarily consider it initially as being of use for you, then there are actually some quite nice application areas in digitalization as well. Though this use case really is mainly about how blockchain is used in the public sector and by data creators, the data donors. So very briefly about the situation in Estonia. Again, Levi delivered yesterday an excellent presentation how everything is digital in Estonia. What was it? 90%, 95% of information is only being delivered in digital form. Paper is more or less non-extinct. Estonia is becoming covered in forest because there is no reason to chop it out. And all the crucial public services are basically online, so I don't know about the count, but there are really thousands of online services from various agencies, ministries, and many of them are actually delivered digital only. So there are really services where when you turn up at an agency with a piece of paper and say that I want to kind of reach in this application, then the public officials start running around and asking what do we do with it. It didn't come through the computer. In regard to blockchain, what we discovered early into the use case is that there are about 50 to 20 major public sector datasets which have started to implement blockchain solutions next to the already available services and data collection and management over the last 3 or 4 years. And out of these, we then selected 2 use cases. The one is already mentioned, the eHealth Foundation, the eHealth Information System in Estonia, but we also went to another institution, which is the Ministry of Justice Center of Information Systems. And that's basically the ministry's IT agency. The Ministry of Justice dealing with all kinds of legal things, property law, business laws, courts, etc., etc. All of this needs an awful lot of different information systems to manage digitally. So there are managing maybe 10 to 20 different information systems, and in 5 of these, blockchain has already also been implemented. just to mention that in the Estonian public sector, basically there is one blockchain provider. It's an Estonian company called K.Aas. That's used by all the public sector institutions, probably just because of the reason that Estonians don't like to talk to foreigners, so they selected an Estonian provider. And that also posed a little problem for the use case. So having a use case about a technology is not necessarily too nice when you only look at one exact piece of technology. And as such, we also went to a private sector institution which is called Funderbeam, and which uses the Bitcoin-based ChromaWave platform for their activities. And it's basically a micro-funding platform. If you are interested in micro-funding, then you can Google for Funderbeam. You can put some money into the network, and you can have a peer-to-peer funding to a startup. So it's startups want to get funding. Usually you can't get, as an individual, as a private person, you can't directly give funding to a startup. You need to go through some intermediate bodies. I don't really know what they're called. There are some financial regulations around that in regard to investment. But with the help of the Funderbeam blockchain platform, you can basically, as an individual, give your 10 or 50 or 100 euros directly to a startup company and support them therefore. So that's kind of how Bitcoin is used there. And next to the users, we talked to the technology provider as well, and we also had some discussions with the policy layer. So we went to the Ministry of Economic Affairs and Communication, which is the main kind of e-government agency or ministry policymaker in Estonia, and we talked to them about their position in regard to blockchain, etc. So that's the whole kind of whole scope of the entire case study. The reports are not yet out. The final reports, we hope, maybe October, or is that too optimistic? So anyway, this year we'll also publish the full reports of the use case. But today I will mainly concentrate on the users, how blockchain is used by these two institutions, and then mainly also come to the conclusions and some proposals in regard to blockchain. So the e-health. The e-health information system in Estonia is the central access point for all high-level medical information. The running argument for the e-health information system really is that if you are in a medical condition, the emergency services come, they want to know about your medical history. Then they can get a really quick overview from one central point. So they can see which doctors have you visited, which medication has been prescribed to you, and all of these kind of high-level information. The detailed information and more sensitive information is mostly still in the individual hospitals and the hospital's information system, but it's really the central gathering point. We gather information connected to a person to get a first understanding on what this person has been through in regard to medical visits, surgeries, analysis, etc. Obviously, this data, even if it's a bit generalized, is still highly sensitive. And in Estonia, we have a central set of national IT security regulations, which require every public sector information system to analyze how sensitive the data is, how business crucial the data is, and appropriately proposes about 3,000 pages of different measures which you need to implement in regard to software security, server room, infrastructure, etc., 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 etc. This system, the security regulations and everything has been implemented already since mid-2000s. And since about 2010, on the highest integrity levels, it started talking about hash chains and also blockchain. So nowadays, it's not explicitly saying that a blockchain shall be used on really highly sensitive data, but it says that a hash chain needs to be used on highly sensitive data. And the e-health system themselves decided to take a step forward and implement and also blockchain in 2016. One of the main concerns which they had when implementing the blockchain was scalability. You heard Ross talking earlier about how mining might take tens of minutes. In the case of Bitcoin network, the private sector discussion we had with Thunderbeam revealed that really it might be even hours, or in some cases, when there is, as an example, an attack towards the Bitcoin network, it might even take a day or more to get a response in regard to sending something onto the blockchain. At the same time, the e-health information system, as you see here, some numbers, into the system there is about 40,000 documents added daily. And these are coming both in as XML and PDF representations in parallel. So it's actually 80,000 files every day. And that's then the information about the visit surgery analysis, etc. And in a system of such sensitivity, you always also need to monitor all the transactions. Who has queried the data, who has altered the data, when it was made, etc., etc. So these transactions are also needed to be secured, and there are about 1 million transactions each day. So it's really a huge load. And with a traditional kind of a Bitcoin network, it wouldn't be too easily possible to get onto blockchain as well at all. Just a point for some of the later slides is also that all documents are already signed using the Estonian digital signature anyway in the system. What the e-health system is doing, again, I suppose the 3 first rows are going to be able to understand and see this picture, but the rest not. So you have all of this information, the logs and the documents are basically, in the end of the day, rows of a database. These rows are taken and put together as hashes. And all of these hashes, one hash per one record or one document, are then built into an internal hash tree of the information system. So you take, as an example, there is one entry into the database and another, a third, a fourth, and based on all of these entries, you generate a hash, and these hashes are then summarized together into what is called a Merkle tree, which I think Roy is going to talk about a bit later. Anyway, the point is that you build a hash tree where you start summarizing all the hashes up, and in the end of the day, you get something which is called then the top of the, or the peak of the hash tree, which basically includes information about 10 or 100 or 1,000 or 10,000 documents. And it's still expressed as a single hash sum. And that's what they exploit in order to achieve scalability in the e-health system, internally in the system. That has nothing to do with blockchain. They build a hash chain, and every second, which corresponds to about 200, 300 documents and transactions, there is one top of the hash tree, which is sent then to the through some middle layer into the quad-time blockchain environment. So effectively, they create one hash in a second, which they also then quad on the blockchain. So that's a really basic overview, but that's just one of the ways on how to get rid of the scalability concerns of a blockchain network, essentially. The other institution, the other use case which we had is then the Center of Information Systems. There are surprisingly many Estonians in the audience, so it's the RIC. And there are 5 quite crucial registers where the same quad-time blockchain is used. The first is the succession register, so for registering all the wills of people electronically. Again, when you're feeling that you're about to die, then in Estonia you don't go to a notary, but you basically sit down, prepare a Word document, and then sign digitally and send it to the registry. If you don't have a computer when you're about to die, then bad for you. Then the e-land register, which is basically about property ownership, e-business register, again, business registration, business ownership, e-file, which is then the court information system for court cases across Europe, across Estonia. And the publications office, so the Estonian publications office maintaining all the Estonian laws and kind of the government regulations. All of this is also managed digitally, published digitally, and maintained digitally. So obviously all of these systems are of huge interest in a legal or personal way. Many of these systems also include private and sensitive information. Blockchain has in all of these systems been in production since 2014, 2015, just as a number. And again, due to the sensitivity, they are not using kind of the way of sending data natively into the blockchain, but they are using also hashes and hash chains internally, and then the hash or the hash chain is ultimately what they also send to the blockchain. So in their cases, they are not using the hash chains as extensively as in e-health. So the system load isn't that big. But as an example, when a new will is entered into the information system, then obviously then there is a will. It might be in multiple file formats, so in XML format, in PDF format. There is some metadata added into the system. That's basically one record. The files, the binary files plus the metadata, all of these are brought together. So again, you take the whole, kind of more or less the database row, technically speaking, you generate a hash, or a hash tree based on all the components, sorry. And then you send the top of the hash chain, which usually has about 4 to 5 components, and that's what you send to the blockchain. Effectively, you get one blockchain entry for each record. The interesting part about this use case was that they have actually encountered a practical need to alter records or to generate links between consecutive records. So one of the native properties of blockchain is that you can't delete anything. If you have put something into the blockchain, then that's where it is. If the record was wrong, there were any input errors, any kind of mistakes in the records preparation process, which you encounter 5 minutes after you have sent it to the blockchain, then there is nothing else you can do. The record is there and it stays there. So technically in a database, it's not necessarily a big issue. You can just have an update record or a next record, which you add to the database. Again, you do the hashing, you send the top of the hash tree to the blockchain, you get a next blockchain entry, and technically everything is fine. But just from the user experience and the user point of view, it would be really nice that you could mark that something, you could also mark in the blockchain, in the chain itself, that something you have sent there earlier was an error, whether it was deleted from the system, whether there is a next record which you should look at instead of the previous one, etc. So it's also part of the archival part of the what they called blockchain provenance, which they were interested in. But that's something which is really missing in current blockchain implementations. So that was the really quick overview of the use cases. Just a few words about the technology. I'm not really doing any marketing for this. It's up to you to decide whether you want to follow it up or not. The company, as said, is part-time, and it's important to note that it's a private blockchain. So Bitcoin is a public blockchain. This is a private, or they themselves prefer to call it a permissioned blockchain. And they offer it as a service, which means that all the nodes of the chain are then managed by the Quartine company itself, or you can just buy it as a platform, and you can implement it on your own premises and in your own servers or with your affiliate institutions or whatever you do, basically. In the case of the Estonian government, there has been a node network set up by the government itself, and that's also one of the reasons of the popularity. The government has set up all the computing and offers quite a simple API, which is for free for any government institutions. And basically everybody we went to all the use cases they said, why shouldn't we use it when we don't have to pay it for it anyway? And that's an extra level of security. In the development of the quarter-time network, they have focused really a lot on scalability. So it's able to process hundreds of requests a second. So even they say to the developers and the owners of the quarter-time company have said to the e-health system that your system load actually shouldn't be a problem. You can also send each individual element and transaction to the Bitcoin, blockchain, and we can handle it. However, the e-health people don't think they are brave enough to test the developers' arguments. And such a scalability and efficiency is then received by exactly what Ross said before. The system doesn't use proof of work consensus, but instead there is a mathematical consensus mechanism. So the ones of you who have a master's or doctorate degree in mathematics, you can be 99% sure that the mechanism is something which you won't understand. So it's a hugely complex piece of mathematics, which has been developed then by the core cryptographers in this company. But obviously, it's also one of the weak points. When you use a public blockchain consensus mechanism, then everything is public, everything is visible. Their argument really lies on the complexity and the privateness of the whole network. So some of the more interesting statements from the use cases. So that's really what the e-health people and the people at the Ministry of Justice said about implementing blockchain. The main thing is that they see the role of blockchain as basically being what Victoria showed earlier, a component in regard to records integrity. Right now, when the technology is more or less still a buzzword, then it's not really that they would look at it as a huge opportunity in extending business, reorganizing all of the business processes, like they have done with in Estonia, partially. But they are just looking at it as an additional layer on top of the usual hashes and the digital signatures, and just having some kind of a continuous, kind of unexpireable mechanism on top of everything else. One interesting note was also that it was mentioned that when usual protection security mechanisms are in-house, so you have your own systems. Inside your systems, you implement some of the integrity and security protection mechanisms. Then blockchain allows you to have a third-party verification, which basically bluntly said was is good for the case when the system administrators start to run wild. Someone comes, pays them a huge amount of money and tells them to change a will. A system administrator who has all the access into the servers, into the infrastructure, might be able to do that every now and then. When you have blockchain on top, then basically just having one guy bought and paid in doesn't help you anymore. You can still validate that something has been altered or changed. And also, it raised an interesting discussion as about trust as a moving target. So whatever, it's really comes down to the point for them that as you have any security mechanism implemented right now, then in about 5 years, 10 years, 15 years, we don't necessarily know when, but at some point these will be outdated, there will be something better, something new. And really what is happening with blockchain, in their opinion, is that it's something which is even more secure than the digital signature, and that's why we implement it on top. But it's not the final solution. Possibly in 10 years there will be something else which we implement on top of the blockchain again. So who knows? Some issues which were raised by during the use case. The first issue really is about what is blockchain. And it became clearer and clearer when we went through the Estonian uses that there is no really defined, no really technical definition of what can you call blockchain or not. When I would present the same technology, the quarter-time technology, to a conference on blockchain, I would argue that about half of the people would stand up and say that's not really blockchain. That's not what you could call blockchain. At the same time, it's distributed ledger. Certainly, there is a ledger, there is a distribution, there is a chain, but nobody has said until now where is the border. What, in a technical sense, you can call blockchain, what not, and that also creates a lot of confusions, which and as such is something which needs to be dealt with. But as far as I understand, Victoria, you have your ISO working groups where also the terminology and getting to a more precise terminology is one of the issues. So that's what the community, the blockchain community, is dealing with. The other issue is privacy. And quite bluntly said, right now you can't really send data to a private data to a public blockchain network. That's the statement. When you send data there, then that's where it is, and everybody can read it in the end of the day. Scale and cost has been already touched quite a few times. Proof of work blockchains can become very costly, and as such, really the recommendation is rather to look towards private when that's an issue for you. And blockchain longevity is something which hasn't really been discussed too much. And I suppose that's actually one of the purposes why I also agreed to co-organize this workshop and to be here to really start a discussion among also the archival profession. What do we need to know? How can we keep blockchain? What are the issues which can raise in 10 years, in 15 years with the current Bitcoin network, with the Ethereum network, etc., etc. So there hasn't been really much talk about this in the blockchain community, as far as I understand, but it's certainly going to be an issue for us. And finally, provenance, which I already touched upon. So it's the point that when you send information into blockchain, then these are individual elements which are in random places in the chain. But every now and then, as a user, to exploit the full capability, or really to go into archival or records management processes, then you would need to know about the provenance in a technical sense. What is the previous file? What is the next file? How are these files related to each other? And that's also something which the archival community could contribute to blockchain discussions. So finally, despite all the issues, blockchain really is, in my opinion, there to say. It's an excellent technology when you understand what its role is. And right now, according to the use cases, the role is in integrity checking. But obviously, as all the more advanced scenarios come up, when we are starting to talk more about smart contracts and really changing the business processes into a more peer-to-peer model, not through a central model, what has happened with Bitcoin, essentially. When we also go this way in records management, archiving, etc., then we need to have a second look. And as such, my recommendation to all archivists who need to deal with digital records in 10 to 15 years is to start looking into what is blockchain, what are its characteristics, and what you need to know about it when you start ingesting blockchain records. Finally, as I said, also through the learning process of going to the agencies, reading about the technologies and starting vaguely understanding what a blockchain is, I also saw that there are two areas which might be beneficial in regard to digital preservation. So blockchain implementation in digital archives. And these are, by now, these are already quite straightforward for me. The first is really to store IPs. When we look at each of the individual IPs as being one version of the information, then through storage, simply we need to guarantee that the IP we have put into storage hasn't been altered. And blockchain, I think, would be a great tool to do that. So it's basically in the same role as in the e-health system, in all the public sector systems. You have a piece of data and you need to freeze it until you need to do something else. A next step in the process is with this piece of data. And for this frozen period, using blockchain would be a really nice way. which has an additional benefit of being able to take your data out of the system, migrate between different systems, have multi-site storage data exchange of these packages. So when the data is on blockchain, then really you don't need a high level of system security, but you have this blockchain security instead. The other is preservation metadata. So you have this frozen state when you have your IP, and at some point you discover that you need to alter metadata, you need to migrate your files to a next file format, etc. And one of the core questions in the deep, detailed digital preservation discussions is how to prove the authenticity and validity of these migration exercises. You need to take away, for these processes to happen, you need to take away any security measures anyway. Blockchain, digital signatures, hash sums, these are not valid after the migration. So the usual approach is that you describe the activity. You describe in quite a lot of detail how you took the PDF file, as an example, out of the storage, how you selected the methodology of converting it to a new format, let's say XDF, a new file format in 2025, and then you do the conversion itself. And all of this information is also quite crucial to be timestamped, to be secured in order to guarantee the authenticity of records. And that's, again, a place where I see that using blockchain would be really beneficial. But that's it from me, and I understand that Kroja is actually going to talk much more about how you could actually do these things.
Yeah,
in real life.
That's a wonderful segue. Thank you so much. While we're switching over to Hervé's presentation, do we have one question for Laura? Waiting. Oh, yes?
So, one of the things that you've not said much about, and I'd be interested to get your reflections on, is what the opportunity is for archives, if you like, beyond the technology. So, does this provide us with routes to potentially create some form of explicit value for archival institutions together? There's a fair bet to bet on our longevity, archival institutions, and there's a fair bet to bet on the kind of trust that we, particularly in a permissioned context, the kind of trust that we bestow on the tools that we use. Archives are poor, small institutions, but you can't help but think that those are, in this world, really big attributes. So how might we turn that into some kind of wider value for our institutions?
I have the answer for that. If you look at the debt market, I mean the private and corporate debt market in Europe, just Europe alone, we're talking about 17,000 billion euros. That's a lot of money. And if you can partner with the banking sector, for instance, and you could keep the logs, the hash logs, in the archival system, and you could have cooperation between different nations, the entire European community would actually trust that data. And if we have a couple of central banks, a couple of Barclays, and a couple of national archives, I think we solved it. And you will also be paid for it, because that is a crucial element, and we're talking about a global infrastructure that needs to be created.
So that's a very intriguing idea, and I think we should come back to that discussion after Hervé's presentation to explore this thought.